Hello, you beautiful people! Another episode of UncleCode Review and another two students. Hello, Sam and Ash.
Hello.
Hello, hello,
How are
Uncle. Hi,
you?
Mesa.
Good.
It's so
How's
nice
life?
to be here.
Right,
Yeah.
right. So we have two another students, one girl, one boy, right?
Yes, exactly.
So
Yes.
let us start from the first one.
All right. So for the first one, we're gonna have Naerah. She is 10 years old,
Wow.
and she actually joined in 2019.
Oh, I remember her.
Yes, really active student.
How old is she now?
She's now 10. So when she joined in 2019, she is 7, I guess, 7 years old, 7 or 8 years old.
Okay, I can see.
Yeah.
Perfect. So 7 years old, joined, and now he's 10 years old. Great. Okay, let's go
Yes.
through it. So I'm going to share my screen. So anything, Sam, you have before we go for the code?
Yeah, this is the practice for the sum function basically, but they do it by themselves before being introduced to the sum function, and of course the average.
Okay, great. So let's see what we have here. We do have Tom. We have the Tom all the time. So we have the X here. We have a function. The name is temp, and then this. Okay, so let's run it first. Let's see what we're gonna get here. Interesting. So we are printing the summation of these numbers, and then divide by the 7 to get the average. So that's really great, and good job, Naerah.
Wow.
Fantastic.
Very good.
So you know what? Summation and average are very two important simple indicator in entire of mathematics and statistics and any sort of data analysis. So if you already know really the summation and the average, you are a kind of data scientist. And you know how to apply to things to work, because this little average summation divided by 7, it's a big concept in the whole mathematics and statistics.
Yeah.
Wow.
You get the fantastic, you always deal with this complexity relevant to the average. So average maybe is the whole things behind the AI and machine learning. So we try to always figure out what is the average, and that's a very important thing. But
Almost impossible to know the personality of your data not knowing its average or length or the sum of that.
it's really interesting, really interesting. So today you did something really cool. You wrote a code here to calculate something which is not in the data. You generate it. It's very important. When you look at these numbers, you don't see average. Nobody talk about the average unless you define it. So you define something. You define something that shows something about a data. Okay, it says that all these numbers are moving around something like 7. Their distance to that number 7 is distributed around the 7 somehow. It looks like when you go to a room and you see, oh, majority of colors are green, so that means the average of colors are green. Somehow you look at the green, you see the green. This is really nice. So we generate something which is not in our data, but it's about the data, metadata. So here I have some points for you, Naerah, to make your code a little bit better here. So I'm gonna do, first of all, I feel bad, but I'm gonna remove the Tom. Okay, I feel guilty. Anyway, this can
No.
Here now, why don't we call it a little bit of better function? There is something here that your function does two things. The function returns summation and calculate summation and calculate the average. So, and you use print because you want to print it and then show it here. Okay, that's a good thing to do. And then here, your function accepts two parameters: data, the list of numbers, and then the size. Well, so let's slowly make it better. Okay, rather than 7, you can use a function in Python which is length to calculate the length of the data. So this is going to do the same thing. So if I want it, you see I'm going to get the same thing again. So let me run it again. So len x in Python returns back the 7, how many elements we have within the x. So that's much better. Huh? If you're going to have more numbers here, you don't want to just, believe me, you don't want to count it. But it's good to count. You increase your counting ability. So that's one thing to do. Then the question is why we are passing this len x to this function when function can do it by itself. Why we do something outside the function when this doesn't have anything with the outside, right? It's very important because you have to think always as when you think of the function as much as possible. If you can make your function pure. Pure means that this function doesn't do anything with the outside world. Everything is self-contained, does everything inside itself, and returns back the value that you're looking for. These functions are good. These are really good, strong functions. They are error-prone. You get lesser error with them, pure functions, or a stateless function. So what I'm going to do, I'm going to remove the L because I don't want to get something extra from the outside. I'm just going to go and then copy this one, and then here, and I write the L equal by this. So now probably I'm going to get the same thing. It's going to work. So now I have the L inside. I don't need to pass it from the outside, so the function get a little bit better. And you don't need to think of how should I calculate the length of the list and whatever. So here now we do, and we can do some extra stuff here. Okay. Then look at here. That I know you printed the result. It's a good thing that you did. It's nice. But I prefer functions to not do the printing. Then it's not pure because it's impacting where a screen monitor. That means it's touching outside world. We like the function to be something self-contained. You give a value, you get the numbers. You don't decide where you want to print it. Give me the numbers, I will decide it. So it's something like that. Imagine I'm talking with your function. Hey temp, you don't do that. Okay, it's my job to print it. Maybe I want to print it. Maybe I want to draw it. Maybe I want to make it like a music. I don't know. I want to turn it to animation. Who knows? Or I want to make it use it in another function. So what I do, I will remove these two lines. Okay, and what I do is I will come and I return thanks to function. You can Python, you can easily return two values. So I'm going to return A, which is a summation, and A divide by L. So here, when I use the temp, so I'm just going to use S for summation and average. So is equal by this. So S will be the summation, and here the A will be the average. I like to change a little bit the name here. I want to make it sum, or I want to make it S like better name. S means summation, huh? So I'm gonna write the sum equal by sum plus I. So it's gonna be a little bit better. So then here, you can write anything. I'm gonna write my sum, huh? Like a may sum. So here I'm gonna write average, my average. Okay. So, and then here now I have two values. And now I can print them. Just I can simply print them. Print this and this together here. And I run the code, and I got it, huh? You see what's happening? I run it again. So I got the summation, and if you want to make it a little bit better, you can write sum like this, and then I'm gonna write average like this, okay? So then I have a little bit better way to help people to understand. Maybe you like to print them in two lines, okay? So just do what you were doing before. So I'm just
look at that.
And if you want to have a little bit better taste of interface, so maybe you're going to like to do them like this, you know. There is a way that you can do that, but I'm just going to write it down like this. So now I like that. It looks better, huh? So sum is 47.7, and then the average is this. And I think that is nonsense. So now look at your function. Your function is much better now. It's self-contained, doesn't do anything with the outside, and everything is inside, self-contained. And that's a perfect and nice functions. And I'm gonna call this like calc sum. So calc sum is a better name. And I'm gonna do this, and I change the X to data. I like to call it data, for example. Okay, so, and then you have this here, and then you have it here. Okay. So now that we have something bad happen here. I got it. Okay, so now you're gonna get the sum and the average. So that's cool. But you know what, Naerah, there is another way to do summation and the average in Python. Python has a built-in function to do that. It means like if you come and write down print sum x, it will do that things for you. That means when you run this, let me clear this one. So it gives you the 47. So it technically is like a function that you route here. And if you want to get the average, so what are you going to do? Technically, you're going to write divide by x. So then that's what you're going to get. You're going to get the same thing, right? But you know what? I don't like you use this, because the purpose is you do it yourself, and then you did it. So this is when you are expert. So
it's a homemade sum function.
Exactly. It's very important. That's the point of this.
I remember back in time we had to write all of them. There
And
was
then
no
yes,
such diversity of functions in programming languages.
and we used to create our own library. Library means I want to use this function again and again, so I keep them in a file. So whenever I need them, I attach them to the main code and I use them. So it's very important that we learn coding like the way that you are learning Naerah. You have to learn rules like a pro, but then you can break them like an artist. So that's what I wish for.
Very nice work.
Yeah, very nice.
Okay, so the Naerah is down. Good job, Naerah. We go for the next student.
All right.
Very good.
Well done.
Okay,
Yeah.
let's go for the next one.
Okay. We have another 10 years old.
Oh,
Yes.
today is
And
10.
and his name is Sanjed. He joined back in 2018.
Oh, look at second
Yeah,
floor.
look.
Okay.
Yeah, look at that. So he joined. He was still doing coding back in before we had our main campus in level 5.
Interesting, interesting. So, Sanjit, right?
Yeah, Sanjed. Yeah, and he's also 10.
Okay, Sanjit, it's your turn, dear Sanjit. We're gonna see what you've done. So let me share the screen. Okay.
Okay.
I'm excited for this. Look at that.
This is a very, peculiar code, I should say. A bunch of scientists and experts and the hackers try to decipher what's happening over here. The output is amazing and beautiful, but I don't know whether he was any, particular reason or no. Let's see. Let's run the code.
I want to see.
Yeah, it's really, really beautiful. Yeah, but you cannot reverse engineering that.
To know what's happened. Okay, let's run the code of Sanjit code. We're gonna run Sanjit code to see what's gonna happen. 2, 1, 0.
Ooh, look at that.
Wow, wow. There are a bunch of things happening, and 100 times. The loop is 100 times. It's
yeah.
Left, color,
Do you see the black lines?
left,
Is there something
right,
Oh,
Yeah.
removing something?
Literally, there's no any kind of. I don't see any different kind of definite pattern here. I think he really created a random art, and that's
It's modern art.
When you look at this first left color circle score, then left color circle right score, then right color circle left, color circle left, and there's no score again. That's beautiful.
What I can say that poor
Sweet.
Tom.
What?
Poor Tom is so confused. Make your mind. Where should I go? But the outcome is very brilliant and beautiful. The more you let it go, the more beautiful it will be.
It is really interesting. Very good job, Sanjit. I'm trying to understand what you have done, but very good job. It's really beautiful. So let's take a look quickly here. We do have a function score, so it's pretty clear what the score does. So if I comment all this part of the code, so we're going to see a bigger score here. It goes left 90 and then forward 400. Wow, 400, and then color blue, and then left 90 in a place that you don't see it in a screen, and then forward 400, this and then this and that. So you know what? Such as always, one of the things that I'm going to say that so you can see there's a pattern of forward color left, then forward color left, and forward color left, and then forward color and no left. So maybe I can come up with the left for color, yes, left forward color and left forward color. So maybe we can play around with this first to use the for loops. You know what? That's something really interesting. If I can really reduce the size of the code by found the pattern recognition, and then put in the kind of for loops, it's the power of the for loops. You're using for loops like a Greek. So you're a master of the for loop. So I'm going to use this one, the same thing here. You have 4 colors: blue, green, red, yellow, and then all the kind of things is a 400. So I think it won't be any problem for us to just use I'm going to write blue, green, and then what? And then red. And
Red.
then, okay.
Yes.
So So here we're gonna have left, and we're gonna have this. We're just gonna write the color. So all removed. So then we run the code, same. So now you have a little bit smarter,
Yeah,
much better, much faster. So, and then now let's go through this. Let's see what you've done here.
oh my god.
Okay, I'm gonna first figure out what is going on. So what is that?
Oh,
Okay.
what was?
This is 100. Let me make it one cycle first. Let's see one pattern. So you go left, a little bit left, very little left. I wonder why you choose these numbers. I'm thinking about it. You're 10 years old. You must have a reason for that. And then you choose black color. So if it is red? Okay. And then you draw a circle.
Left color circle right. Right color circle left.
And then a square. You draw a little square. Okay. Then you went right 90. Change the color. And another circle.
Can we figure out a pattern into that? Left color circle
Right
square.
103.
Left color circle right square. Right color circle left. Color circle left color. Oh my god. I give up. All right. Okay. Then now go to lime color and draw another circle. All right. Going left 66. Why 66? And then go yellow. Then another circle. So big.
I think this is a code
Big.
sage.
All right. Yeah, it should be.
And you have to come and explain
Only another spy under and then
what is
understand
happening
it.
here. I'm really understand. We have two little circles. We have So it's really interesting, huh? The shapes that we just saw is 100 of this. 100 repeating these patterns 100 times. It's moving. It's really interesting. And actually, that's what inspired many artists. Generative art, many artists inspired by this technique. That means we create a pattern, a generative pattern. You know what I mean by generative pattern? If you draw, Sanjed, if you draw a square and repeat it 100 times, you won't see anything. You just see one square. But whenever you draw a square, you just go a little left or right, then you see a pattern. This is generative pattern. A generative pattern, back to generative functions in mathematics, which they are kind of recursive functions that the new term is different than the previous term. Wow, I'm talking about generative functions, is a very difficult topic. But look at counting. You never count 1, 1, 1, 1, 1, 1, 1, 1. We say 1, 2, 3, 4, 5. So something is getting added. So that's the generative way of generating numbers. So new numbers is the previous numbers plus 1. So that's how we go for the next one. Generative patterns, they have this ability. If you build a generative patterns, you just drop it to any for loops, you repeat it, something beautiful will happen. Something that we don't know. So many people, they say that the structure of atoms and molecules, they are forming through their generative patterns. So evolution is a kind of for loops. It's keep repeating, and not all the times we go right like 20 degrees. Sometimes something happened that 20 degrees will be 80 degrees or 70 degrees, okay? And then mutation will happen, and then something else will happen. And those beautiful shapes, we can see them, and they can survive, and they can go to the shapes. So generative patterns are really important in physics, in statistics, in game theory, in chaos theory. They have a lot of applications. And here, when I repeat this 100 times, let's see what's going to happen again. Something will happen. A new universe. That's your universe, Sanjed. You created a universe that looks like this. Very beautiful.
That's very, very nice. We can talk, for example, 3 hours about philosophy of things. No, back in time, the alchemists that's starting to adding random things together and see what's come up. They just some scientific guess, and let's try this, see what happens. And out of the outcome, we try to find some patterns and repeat that experiment, and find a lot of discoveries has happened like this. This, oh no, it could be a very interesting pattern. It's beautiful, of course. It could be any other things coming out, and that will bring us to learning something new and new and new. There's something good about computer science. The price of doing such experiments are absolutely negligible compared to other science. If you want to try, like, I don't know, cooking stuff, like adding rice and milk and ketchup and things like that, and repeat it 1,000 times, your mom will kick you out of the house.
Yeah, exactly. Sometimes you get surprised by, oh, I'm not a good chef, but why become like this?
Before you're getting something interesting out of it.
Very interesting. Well done, Sanjit. Beautiful, beautiful. That's just what I like to see, to show that coding is a laboratory for creation, for building, for trial and error, in just a matter of time, and nothing can stop you to bring more stuff like this. So this is just a sample of the same thing that make us so curious to send a probe to Mars and a drone to Mars to fly. So all this kind of randomizations, trial and error, bring us to that very important point. So I wish something beautiful for you and Naerah to continue this loop of your life, repeat of your life, and then when you back to your life, you see something beautiful like what you see in this screen. I hope your life patterns.
Very nice work. Very nice work.
Yeah, very wonderful. Yeah.
So that's all, everybody. It's interesting. I really enjoyed from these two. And we're going to close it up. And Naerah and Sanjed, remember that you are programmers.